Imagine a highly simplified building exhaust system. Exhaust fans blow air out of the building. Outdoor air intakes allow makeup air to enter the structure. General ventilation systems such as this can be used to dilute contaminants in the workplace air. For instance, imagine a worker is welding indoors. Welding creates a fume that becomes airborne. If there is no ventilation, the fume may reach hazardous concentrations in the indoor air. General exhaust ventilation may be used to pass large amounts of outdoor air through the workplace to dilute the concentration of contaminants inside. A different form of ventilation, known as local exhaust, may be used to capture contaminants at their source before those contaminants have a chance to spread through the workplace. In this simplified system, contaminants are drawn through a hood and pass through a duct to be cleaned by a filter. The filtered air is then exhausted back into the workplace. If we do not wish to exhaust the filtered air indoors, we can use longer ductwork to connect the hood with a filter located outside. Local exhaust systems are powered by fans that move air through ducts. The fan creates suction or negative pressure in ducts that lead toward the fan. A pressure change is created across the fan blades so that ducts leading away from the fan acts as blowers. Pressure in the blower ducts is positive in relation to the surrounding environment. The total pressure within a duct can be thought of as having two components: velocity pressure and static pressure. Velocity pressure is pressure that is exerted only in the direction of airflow. Static pressure, on the other hand, is equally exerted in all directions within the duct. On the suction side of the fan, static pressure is negative. If the duct is made of weak material, negative pressure or suction may cause the walls of the duct to collapse inward. On the blower side of the fan, static pressure is positive. If ducts are weak on the blower side, positive pressure may cause the duct walls to bulge outward and burst. Once again, total pressure consists of velocity pressure and static pressure. On the blower side of the fan, velocity pressure is exerted away from the fan in a direction parallel to the duct. Static pressure, on the other hand, pushes outward in all directions in a blower duct. On the suction side of the fan, velocity pressure is exerted toward the fan in a direction parallel to the duct. However, static pressure on the suction side pulls inward in all directions. We can measure duct pressure with a manometer, which is a U-shaped tube containing a liquid such as colored water. To measure total pressure, we connect the manometer to the duct with a curved tip that points into the airstream. In a blower duct, positive total pressure pushes the liquid in the manometer away from the duct. The difference in the heights of the column is the value of the pressure. For instance, a difference of 2 inches in the columns of a water manometer would indicate a pressure of 2 inches of water column. In a suction duct, negative total pressure pulls the liquid in the manometer toward the duct. To measure static pressure, we connect the manometer to the duct with a straight tip that is perpendicular to the airstream. In a blower duct, positive static pressure pushes the liquid in the manometer away from the duct. In a suction duct, negative static pressure pulls the liquid in the manometer toward the duct. Pressure causes air to flow. More specifically, air flows from areas of higher pressure to areas of lower pressure. Stated another way, air flows from areas of relatively positive pressure toward areas of relatively negative pressure.